For today, we're going to go over exponential growth and decay. So this is very similar to what we've been doing this whole time with exponential functions. Y equals A times B to the x power, where A is our y-intercept, and B, on the notes, it says growth and decay. We've been calling it our multiplier. And today we're going to learn why we call it growth or decay. So for this first one, this y, we've changed now to p of t. We've changed the a to the p sub 0 is what that's called. It's just the y-intercept. It's your initial, in this case, it's your initial population, because growth and decay, we're typically going to talk about population. So the initial population is my y-intercept, and then my multiplier gets broken down into this 1 plus r. R is our growth rate, and x is now changed into t, which stands for time. Same thing for decay, except notice that in growth we have a plus, and for decay we have a minus. Growth, you're going up, decay, you're going down. So for growth, if we wanted to look at a visual, we're starting off at a small population. We're increasing, and then we quickly increase. For decay, we're starting at a large number or a large population. We're going down very quickly, and then we start to even out. Okay, so that's the visual representation. All right, let's go through a couple examples together. So Zootopia has a population of 20,750 animals. Its population is increasing at a rate of 2.7% each year. What will the population be in 7 years? So the important things that we are looking for is the initial population, which is the 20,750. Our rate, which was 2.7%. Now notice it's a percent over 100. So 2.7% over 100. Now I need to divide this out. It needs to be written as a smaller decimal. So 2.7 divided by 100 is going to be 0.027. That is our rate. Okay, that is a big mistake that students commonly make, is not dividing by 100. And then for time, we want to know the population in 7 years. So let's solve. Showing our work. So the formula is P of T. Oh, T stood for 7. So P of 7. What's the population in 7 years? That's what that means. Equals our initial population times 1 plus r to the power t. Oh, I think I jumped a step. That t should have remained. I haven't plugged my numbers in. Okay. Now, P of 7, what is our population going to be in 7 years? Equals the initial population times 1 plus my rate that I found as the percent divided by 100 to the power of t, which is 7 for 7 years. Now for this, I'm going to use my calculator. I'm going to do everything inside the parentheses first. So 1 plus 0.027. You might have been able to add that in your head. So 20,750 times 1.027 to the 7th power. So I'll go 1.027. I'm just following my order of operations here. So parentheses, next comes exponent. And I don't necessarily want to write that whole number down. Ooh, that's quite a large number. So I think I'm just going to, at the beginning, plug in exactly what I see. So 20,750. So it looks like P of 7 equals 25,000, 4. I'm not going to care about my decimal at all because we are talking about animals. Animals come as whole entities, not parts. So we're just going to round it to the nearest whole number and explain my number in context. So in 7 years, there will be 25,004 animals in Zootopia. Okay, you can do the next two examples on your own. And let's look at one decay problem. So Cool City has a population of 508,805 people. So that's my initial population. Its population is decreasing at a rate of 15.8% each year. So we need to divide that by 100. What will the population be in 85 years? So let's find what our rate is as a decimal first. So 15.8 divided by 100 is 0.158. Now we are using the decay because my population is decreasing. So P of T equals the initial population times 1 minus the rate to the power of time. So P of 85 equals the initial population times 1 minus my rate to the power of time. I'm just going to take this into Desmos. I'm going to plug in exactly what I see. Times 1 minus 0.158 to the power of time. So that means that P of 85 equals 0.228. All right, so if we're talking about people, it looks like in 85 years, no one will be left. I'm left with a decimal. So no one is left in town. I have a decimal. I have less than a whole person, so no one's left. Go ahead and try the next two on your own.